Hello, this is the Blast Report podcast on all things blasting. My name is Evan Tebow with New Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast.
I said Western Pennsylvania was like the Wild West.
Holy cow.
It was the Wild West. I mean, I was lucky because coming in there with the new product, I could go to Danny, and I sit there and I sat down at the house and I drew up a whole bunch of patterns with 42s and 72s or 17s and da-da-da-da-da. And I put a little manual together and made like 30 pages or whatever. And I went to Danny Kahn and I said, what do you think about this? He said, oh my God, this is wonderful. In other words, I can take this out with my blasters, and if they have a shot that looks similar to this, they can just follow that timing because it was new. I remember working for Peabody Coal and Daryl Brown.
I probably still have one of those pattern books. Nick, if I dig through my boxes enough, I'm sure I do.
Okay. Well, Daryl Brown came out and he said, we're going to shoot non-electrics today. We're going to put 42s down the face. We're going to put 25s back. I said, whoa, no. You can't do that. And he said, no, that's right. I said, whoa. You put 42s, they're all going to go off the same time. And he said, no, this is not. So I remember, as feeling that way, like you can't. So when you went and talked to an electric cap guy, you can't be putting the same damn cap at the same hole.
Because they're called number 42s.
Yeah, and so I remember, but Western Pennsylvania in 1980 through the 80s was the Wild West as far as distributors and characters. God, for as a
we always called
Earthquake Ernie is what
we always
Taylor
called
was talking about.
Mick. We always called easy debts dummy debts.
Dummy debt, so easy.
So
dummy
easy.
can do them.
Yep.
Yeah, just snap them
All
together.
you know is you hook this one up, it's going to shoot before this one shoots.
Yep. Just hook them up. Let's see, who was that there in north of Indiana, PA? It's another DuPont distributor, Stockdale and Means?
Yeah.
Stockdale
Steve.
and Means.
Yep, Steve Means.
Yeah, Steve Means.
Yeah.
And God, these guys were every 20 miles.
Yeah, just about.
They were literally,
Well, there's a lot of haulers within 20 miles.
Yeah.
And then there was who were the Italian boys up in Clarion?
Tyler Blasting?
Yes, Tyler Blasting.
And they were Italian.
Yep.
You're right. Tyler Blasting. Yeah, I got along well. I brought up a video camera. And it was a video camera. And you push the button on it and it actually takes a picture, and then I can roll it back and you can actually see it in here. You're shitting me. In 1980, 82, that was like, what? Because you movie cameras, and Mike, you went through a bunch of this, high-speed cameras. God, we burn up a bunch of film wrong shooting high-speed cameras. No, because it ripped that through there in like 4 seconds.
Yeah.
And so if you didn't, you had to time it to turn the switch on and zip, it'd rip it through there. Well, the video camera, we would get 35 milliseconds per frame, which that wasn't a high speed. I got it. And of course, the big boys would always criticize. The big boys didn't want to do anything, but they wanted to criticize those who did. And so they were saying, you can't, so you can get an idea how the blast goes. I can see if something goes out of sequence. In other words, I'm videotaping this shot. But anyway, the Tyler Blasting guys, there were certain people that just really loved that, the videotaping and all that kind of stuff.
Well, now, on that same subject of videotaping and technology, that was unheard of for you guys. And now it's pretty common for people to have a video camera from the back.
I can do slow-mo on this.
Yes.
Yeah.
Yes.
On my smartphone.
And we see it every night on the news. People, just clicks this up and they've just caught this volcano or whatever.
In the last 5 years, drone photography, so you can actually get something from above and see the muck pile movement, and you can see some witnesses fire at the back end of your dual delays. So you could essentially walk a pattern, with the camera at the beginning before you go up there, and it's pretty unbelievable being able to access if you're shooting from a hillside where you don't have ability to put a camera up, and if you have a drone, you can now actually film a shot that you would not previously have been able to make any scientific decision unless you had video of it.
Yes. I think from a perspective, I guess the other side of that is from understanding what we're actually blasting, being able to record without having to have no production involved in it, blast is again one of the largest advances we've had, because you can actually see in real time what a blast actually does. And the quality of it, as Mick was saying, 35 frames, I mean, wow, that was just, or 35 milliseconds per frame was just incredible. But I can set this thing up and I can shoot 5 milliseconds a frame.
Correct.
So
Correct.
the point is that is understanding. So electronic detonators and the quality of the video that we get from Blast now, those two things are the things that have really, really brought us leaps and bounds forward to where we were 30 years ago, 40 years ago. We had a friggin' camera that was on a tripod that took a frame every half second, and we thought that was really cool. Once you got the
really cool.
Once you got the film developed, we thought it was really cool.
Once you got it developed,
Yeah.
we had to actually mail it off,
Mm-hmm.
and we used to ship it from Southern Indiana. We would ship it down to Louisville to get it done and bring it back. And so you tell people, probably next Thursday, Friday, we'll
You'll
have
see how
that
it works.
film
Video.
back.
Yeah.
Yeah.
So that has created. Now, I'm not convinced that we still know everything that we should know, because Mick will go out and shoot a shot and he may shoot 30 milliseconds down the face and 90 between rows. And I'll go out and I'll shoot a shot. I might shoot 17 down the row and 67 back. Well, both of them have good results, but the question is, are we both wrong? Is that the reason why the results are similar? Because we both can't be right. So I still think there's a lot of
Artistry.
yes,
That's science.
yes, that has to be involved in to see exactly. Now, the other part of this is that, and again, you asked me what's the hardest. Somebody said that's the hardest record. No, it's understanding exactly how rock reacts to explosives and knowing what to do with that in order to create the best results in a blast. The thing, if you really, really, really want to understand blasting, you cannot just think on the surface. You have to think in the rock. You have to be able to see it three-dimensionally. If you want to be a, that's fine. If you want to go out and load holes and just make this hole go off for that hole, that's great, and get paid for it and go home, that's great. But if you really, really want to understand blasting, you have to think about it in 3 dimensions. You just can't think about it in 2. And that's the difference between what makes a blaster and what makes a professional blaster, are those 2 things. You give a guy that's good at this, take him to a quarry he's never shot before, you give him 3 shots, he'll come damn close to having it figured out. He may not have 3, but he will get close to it in 3 shots. I've walked into quarries that guys have shot for years and have not figured it out. Because they're just blasters. They just get paid to throw powder in the ground, make it go off and go home. So that's the difference.
What would you want to, like, if you had an opportunity to reduce a variable on a pattern in today, what would be one of the variables that you want to minimize now? For example, with technology, not just
blast design.
Blast design.
That's absolutely paramount. We have the technology to create the perfect blast, but I think where we're lacking is proper application of blast design. So is there a difference between a 13 by 15 pattern and a 14 by 13 pattern? Or what is the relationship between the holes that dictate the outcome of the shot? So the drilling is the most critical part of the process, because it starts the whole process. So if there's just so much we could talk about this stuff because
There
I've
is, yeah.
I've seen patterns that if I did a 3/4 offset, that the shot became much better than a full offset. So what I'm saying is that if I'm drilling a staggered pattern on a 15 by 13 pattern, well, that 15 may not be exactly in the middle of 6 or other way around, may not be in the middle of 7.5 on my pattern. It may be 9 to one side. So that's when you really have to understanding the rock structure and what's the best relationship between the holes. And some of the stuff sounds completely crazy, but in particular in granite formations, not so much limestone formation, because limestones are pretty predictable. But when you run into parts of the country, well, it doesn't matter if it's New England or whether it's the Rockies or the Cascades or whatever, it's the relationship of that blast design and the timing. You got to tie all those pieces together to come up with the best shot. So it's really, I would say blast design is the thing that we have to figure out now in blasting. And you just don't go out and say, okay, this is the pattern, this is what we shoot, go drill it, everything's cool. That's not it. There's a real fine line between maximizing the amount of rock you shoot per pound of explosives and a shot that'll actually freeze on you. There's real fine. Most of our industry, we probably overshoot rock by 20-25%. And the reason being is to compensate for those errors. So we don't really push it out to the end of the envelope, because if we did that, I'll give you an analogy. Several years ago, I'm going to say late 70s, early 80s, I think it was Muirfield up in Ohio. The lightning storm came over. Lightning strike sent 3 professional golfers to the hospital. I forget exactly who it was, but anyway, they made big news. So they asked Lee Trevino. They said, "Well, Lee," said, in light of this, when a lightning storm approaches, what do you do?" Lee Trevino was a professional golfer. He was a Latino from Texas, just had a great sense of humor. He said, "I just take my one iron in my bag and stick it straight up in the air." And they go, "But doesn't that attract lightning?" Lee said, "Hell no. Even God can't hit a one iron."
Yeah, right.
So my point is that, again, we have a tendency in the explosives business to overshoot rock because it covers up some of those errors. I can go out and hit a 6 iron all day long, but I cannot hit a 1 iron. And that's my point, is that we have a tendency to shoot just to compensate for those things we don't know. We think we're getting great shots, and we are getting great shots, but we're not getting the best shots because we've not extended the powder, the work of the explosives, as far as we possibly could. Again, we could not do this before the electronic detonator came into the market because it's too much of a variable.
Mm-hmm.
So anyway.
Well, back to your point, Mike, talking about the blast design, you could have a perfect design, but if you have an imperfect detonator, it just wipes you out. I mean,
Exactly
the drilling's
right.
the same way. I mean, the idea that I need to drill this hole from collar to bottom, but if all of a sudden a hole deviates away, you've just wiped out my design.
Yes.
And I try to emphasize that because drilling used to be, just get some holes drilled.
No.
And now we're saying, wait a minute, if that hole's not where it is, then we, we've got a
Good
problem.
blasting comes from some good drilling.
What's interesting, and I haven't been around it enough to watch the smart drills,
Mhm.
what they are, but I'm assuming they are very accurate.
Oh, they're absolutely incredible, Mick. You can actually download a log from them that you can see what the penetration rates were. The deviation penetration was for every foot.
Yeah.
You can cut it down to 6 inches if you want,
Okay.
because they have enough computer power on them to generate that kind of information. It's just amazing.
Well, and as you know, in the coal fields especially, you could have half a dozen different rock formations in that high wall.
Mhm.
Now, in Chicago, in a quarry, no, it's pretty solid limestone. And of course, we're all hoping for solid, consistent rock.
Yeah.
But Appalachia it was incredible there, in Appalachia watching those folds. God, you know how it heaved that thing up, and there was
bend it in
coal
half.
seams that were almost vertical. I mean,
Mhm.
they should have been horizontal, but they heaved up, And you're thinking, man, that had to be a wild day whenever
Those anti-con,
earthquake-wise, when it's pushing up the entire mountain range, and then now you come in, now you're going to drill it and shoot it, you know, and it's not only tilted this way, it's tilted some,
Exactly.
other way, and so
I guess my point is the tools. I think the tools are out there. The question now is, where do we go to figure out how to use them? Because we have all the tools at our disposal, from the high-speed video to the accuracy of the electronic detonators, to the onboard computer that logs the drill holes as well. So the question is, how do we take all of that and create? And I'm not talking about your standard pat just driller office and your hole goes here. I'm talking about actually understanding what is going on in the ground and design your blast based off that knowledge.
Absolutely.
Yep. Good.
Absolutely.
Good.
Well, Mike, thank you so much for being
Sure.
a guest
You
on the
bet.
show.
No,
Wow.
it was great.
I really appreciate it,
Fantastic.
hearing some
Probably
good
lasted
stories.
too long, but
No, it's good. No,
No, that was-
we'll cut it up into some different episodes. So we'll do 30-minute episodes, and we'll edit it up. The team from Blast Think that's in
We'll
Portugal.
see you at 6:30 in the morning.
Yeah.
Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.